a polynomial? It's the sum of one or more terms. X squared plus 3x minus 4 with no division and no fractions. What's a polynomial term? It can be a number like 4, can be a variable like x, a number and a variable multiplied together, 3x. With no addition and no subtraction and with no negative exponents, that is a polynomial term. What's a monomial? It's a polynomial with one term. 2xy squared, one term, a monomial. What's a binomial? It's a polynomial with two terms. 2x plus 4, two terms, a binomial. What's a trinomial? It's a polynomial with three terms. X squared plus 5x plus 6, three terms, a trinomial. What's the degree of a term? The degree of a term is the exponent of the variable. X squared degree 2, 5x degree 1, 6 degree 0. What's the order? Put the terms in order from the highest degree to the lowest. X squared degree 2 first, 5x degree 1x, 6 degree 0 is last. That's a polynomial. That's a polynomial.
Hey everyone, welcome to Big Ideas, Chapter 4. We're looking at polynomial functions, and just like that video was describing, it was kind of an introduction a little bit to the polynomial functions that we'll kind of look into a little bit today in 4.1. We're going to be graphing though these polynomial functions in 4.1 that we're doing today. But then as you can see here, here's the order what we're doing. We're doing all the order just the different operations. We're factoring, we're solving equations. We're looking at some different ways of seeing these transformations again. There's that. We've seen that now a couple times with transformations. So let's get into chapter 4.1. So 4.1 is the graphing of the polynomial functions, where we're going to identify polynomial functions, graph them using tables and end behavior. Before we do that, let's just do a little cartoon. So here's a quick cartoon. So it says, the school's new hall passes proved to be extremely effective in discouraging frivolous trips to the restroom. This guy's walking down with this huge sign, I'm missing an important educational experience because I have to tinkle. I always love that one. Alright, so here we go on to our notes now for your polynomial functions. Page 78 there in your notes where your vocabulary is. Let's go ahead and just copy a couple things down here. So polynomial is one of those, and it says, I recall that a monomial is a number, a variable, or a product of a number and a variable. That's what that song was just describing. And one or more variables with whole number exponents. Well, a polynomial is a monomial or a sum of monomials. So that's what a polynomial is. So you're adding or subtracting these monomial terms, that creates a polynomial, which we can describe them as a binomial, a trinomial, and those are 2 terms, 3 terms, like the song was saying. So go ahead and write that down for polynomial. A polynomial function, okay, is going to be in this form here, and obviously when it's in polynomial function form, it's going to use the f of x, so you can say this is when you have f of x in front of your polynomial, basically. F of x equals the polynomial. But you might want to also write this down for polynomial function, that the exponents are all whole numbers. So they all have to be whole numbers, which means they cannot be negative. That's another thing that song was saying. You can't have any negative exponents. And the coefficients are all real numbers. So our coefficients here have to all be real numbers that are in front of our x's. Now, on page 77, if you go back a page, underneath the exploration number 2, we're not writing anything there, so I think this is a good place to put this little chart, which is the common polynomial functions. And I want you just to write down really just these 3 columns that I highlighted. You don't need to write down the standard form column, but just write the 3 columns here. You can do a quick little line across the top, and then one down here, and then just go across and do a few lines there. And the degree here would be 0, so that would be what the exponent, the highest exponent of that term is 0. And that would be a constant term. And here's an example of that. F of x equals just negative 14, just a number. So it could be a positive number or a negative number. That's a constant term. Remember, f of x is like your y. And we've seen these before at the very start with 1.1. We saw that y equals negative 14. If it just equals a number, that's a constant term. If it's degree 1, that's our linear functions. So a linear function is a polynomial. It's a binomial with mx plus b. So this is a polynomial, but we more specifically know it as a linear function. So that's degree 1. If it's degree 2, it's quadratic, which we've also seen before as well. Here's a trinomial, as you can see. And you have your x squared. So you have your 3 terms, x squared, x term, and the negative 9. That's your quadratic. As long as you have an x squared, you're going to have a quadratic. I mean, you could be missing these last 2 terms, it would still be a quadratic. It would still be a polynomial function as well. Now as we keep going on, we're going to see a degree 3 would be cubic. We would call that a cubic 1. That's when you have degree 3 here. And so that's your highest degree of your terms. The degree is always the highest number of the term, or highest exponent of your terms. So the highest exponent here is 3. Even though you have an exponent of 2, this would be an exponent of 1. Your highest one is 3, making it a cubic function. Degree 4, if your highest exponent is 4, we call it a quartic function. So you have x to the 4th here on this one. And then you have whatever's after that. You could have an x to the 3rd, x squared, x term, and a constant term. That could be all after that, but the highest exponent you would have would be an x to the 4th. So even though this still is a trinomial, this one's a trinomial, these are different types of functions because your highest degree is a bigger number. Now, another thing I want to look at is, we're going to graph these. We've already graphed constant functions. That's just a straight line going across, right? We've already done those, straight line, flat line, horizontal line going across. And you might want to write that's what this is. It's a horizontal line. This one here, we know what the linear functions look like. That's just a straight line as well, but usually it's a diagonal line because it has a slope. Okay, so it has a slope here. It's some kind of diagonal line with this mx plus b. We know the quadratics, those are our U-shaped, and they could open up, they could open down, but this is a U-shaped function. Okay, so I just added in this other column here. Go ahead and do that as well, what the graph looks like. So that's why I was showing you here. Those are the 3 we just talked about. And then the cubic one, this cubic one is kind of more like the shape of a snake, kind of going up. So it's more like a shape of a snake doing this kind of thing, going up. So it's kind of like that shape, going this way and then going up like that. So I kind of think this is kind of a snake shape. And then the quartic one, this one is actually very similar to the quadratic. It is a U shape, but it's a little more flat of a U down here. So it's a little more flat at the bottom. So it's a U shape as well, but a little more flat. So it's that kind of shape. So it has the same characteristics. We're going to see that in a minute. All right, let's move on. Okay, so now on page 79, our extra practice. These first 4 problems is asking us to decide, first of all, whether the function in front of us is a polynomial function. So that's going to be a yes or no question. And then if so if it is yes, then we're going to continue on and answer, write it in standard form, which would be descending order, like the song was saying. It's going from highest to lowest as far as the degree goes. And then state its degree, state what's the highest degree of its terms, what's the highest exponent of the terms. State the type, what's its name, like we were just talking about. And also, what's the leading coefficient? That would be the coefficient of your leading term, your very first term, which would be the highest degree term. So with number 1, is this a polynomial function? And it is, yes it is, because you notice that it's got all your coefficients here are real numbers. Okay, so those are all good. And they're also, the exponents are all real numbers as well. So you got all your exponents are real numbers. All your coefficients here are fine as far as those as well. Okay, so we're going to say yes for this one on number 1. And remember, there's just really those 2 things. The exponents have to all be real numbers, or no, sorry, not real, whole numbers, and the coefficients have to be real numbers. So these exponents have to be whole numbers, which means they can't be fractions, they cannot be negative. And the coefficient numbers, the numbers in front here, all have to be real numbers, which means they can't be imaginary numbers. So we couldn't have any imaginary numbers along there. So it's a yes for this one. So we're going to order this, put the highest degree first, just do it in descending order. So it's going to say f of x is equal to the x to the fourth term first, negative 3x to the fourth, then the x squared term, then the x term, then the plus 1. That's just ordering it from descending order. And so then we're going to also state its degree. Well, it's 4 here. The degree is 4. So we'll say that, DEG for degree. It's the highest exponent that's in this one. And if it is a 4th degree, we call it a quartic. That's its name, that's the type. And its leading coefficient, so that would be the negative 3 up in front of that x to the 4th term. So negative 3 is the leading coefficient. Hey, number 2, looking at this one, so we want to ask ourselves those two kind of questions. The exponents have to all be real, or keep getting that right. Exponents all have to be whole numbers. They can't be negative or fractions, and these all have to be real numbers, no imaginary numbers for these. And if you look at this term, so this term's fine, but this term here is a problem. 7 over x. Well, we don't want to leave the x at the bottom, so we can move it to the top by making that exponent negative. So that's the term. It's a problem because that term actually really is x to the negative 1 power. And that makes a negative exponent, which that means no, this cannot be a polynomial function because it has an exponent that's negative. So we just say no, and we're done with that one. So we just had to identify that this term right here is not going to work for a polynomial function because it has a negative exponent. Number 3, there's no negative exponents. These numbers here are real. They're not imaginary. There's no negative underneath here. So if it was a negative 15 under there or a negative 5, then it wouldn't have been. But this is fine the way it is. So these are real numbers. Square root of 15, square root of 5 are real. And as far as descending order, it already is in standard form. So we can just say it's already in standard form. We don't have to rewrite it, or you can just write that. So that is in standard form. This is first, then this would be second. This one, what's the degree for this one? It would be 1. So the highest degree here is 1. It is a linear function. That's the type. Okay, so when it's degree 1, we know it's linear, and our leading coefficient is just that square root of 15 in front of that first term. And always leading coefficient is that one in front of the first term when it's in standard form. And number 4, p of x here. So as far as our exponents go, they're all fine. That's a whole number here. This would be a 1. This one doesn't have an exponent. And as far as the coefficients go, these are all real numbers. There's no imaginaries. If this was a negative 3 underneath here, then that would have been bad. But it's okay because it's a positive 3. So we can say yes on this one, and then we'll just write it in standard form or descending order. So it's going to put the x squared term first, the highest degree first. So negative 2. So that's that term there. Next term is the 3x, and the last term is this constant one going in the back. And our degree is 2, because that's your highest exponent on this one. And then if it's degree 2, we call it a quadratic. That's the type. And then also the leading coefficient would be the negative 2 up in front. So negative 2 is our leading coefficient. All right, let's move on to the next two. Okay, so problem 5 and 6 just wants you to evaluate the function for the given value of x. So here's our function here, the h of x function. It's a polynomial function. It is in standard form, descending order. We want to evaluate it for x equals 2. So that's our input number. We're just going to plug it in and find the output number, which would be your y. So remember, h of x is the same thing as y, so you can think of this as your y here. And so as we start plugging in 2, we're going to say, okay, the 2 is going to go here. There's an x right there. We can actually put the 2 right here now and call it h of 2. And so that just tells us that we're going to now plug in 2 to our function. And so we'll do that to the first term. So that'll now be a negative and then 2 to the third. So we're going to do the 2 to the third first there. And then we're going to go negative 2 times 2 squared. Again, do the exponent first. And then on this one, it's going to be negative 3 times the 2, and then plus the 4 at the end. So for your first term, we always got to do our order of operations as we're working this out. So we're going to be working on the exponents first here. which this is going to be 2 to the third. That's going to be 2 times 2 times 2, which is 8. And then 8 times the negative in front of it, so it's just a negative 8 for your first term. 2 squared on this one, that's going to be 4, and then 4 times the negative 2, it's in front, is also another negative 8, so another negative 8 there for the second term. This will be negative 3 times 2, so negative 6, and then plus the 4. And then we're just going to start putting these together. Put the first two together and make negative 16, minus 6 plus a 4. Then I can put these together here, and that's going to end up being negative 22 plus the 4. And then just negative 22 plus 4 is going to give us negative 18. So we can say our y is equal to negative 18. Now what we really have now is an ordered pair for this function. So as if we're going to graph the function, we can now use these as ordered pairs. You can always plug in numbers for x and find a number for y. So that is essentially the answer to the question they want here, but we also can write down this is the ordered pair that is on the graph of this function. So 2 comma negative 18. All right, so number 6, go ahead and I'm going to pause the video and then try number 6, do the same thing with negative 4, plug it into here and see if you can get the right y number, the output number. Go ahead and pause the video and do 6. Okay, so hopefully you finished and did 6. You have a number for the answer for this output. So we're going to now put negative 4 in here for x. So it's g of negative 4. That tells us we're going to plug in negative 4 for x. So it's going to be negative 4 to the 4th power, and then minus 32 times negative 4 squared, and then the plus 256 at the end. So this negative 4 to the 4th power, we want to basically multiply 4 times itself, 4 times, and then also the negative is affected here by the exponent, so there's 4 negatives. An even number of negatives is going to be a positive. So if you ever have even number of negatives, it's always positive. Odd number of negatives will stay negative. So here you can see we're just going to multiply 4 times 4, do it 4 times, that's 16 times 4, oops, hit the wrong button. 4 times 4 times 4 times one more times 4 equals 256. So our first number there is 256, and then we're going to see negative 4 squared is 16, and 16 times 32, 16 times 32 on this one is 512, but we're going to see this is going to be a positive 16 times a negative 32, so that's a negative number there, so negative 512, and then the plus 256 in the back. And so now we're just going to put these together. If you want to put the two positive ones together, you can. So you could do that, or you can just subtract, go left to right, and do 256 minus this, which would give you negative 256. And now as you do that and put these together, you're going to end up with 0. So y is equal to 0 on this one. So essentially 0 is the answer to the question they're asking here. But we know that we can make an ordered pair out of this. X is negative 4, y is 0. So that is an ordered pair that's on this quartic function here. All right, let's move forward to the next one. All right, before we do that, let's do a little quick joke of the day. What do dinosaurs use on the floors of their kitchens? If dinosaurs had kitchens. What do dinosaurs use on the floors of their kitchens? Of course, they would be using reptiles. Reptiles. Okay, so back on page 78 in the vocabulary, end behavior is what we need to talk about right now. And this is what you can write down for end behavior, that it is the behavior of the graph as x approaches positive infinity or negative infinity. So it's the behavior of the graph. So if we look at this core concept, our graph here is in blue. What's the behavior of the graph as x approaches positive infinity and as x approaches negative infinity? So that's what we can see here. And there's got 4 different kinds going on here. So we need to keep these all straight and understand them. So we have 2 things here. We have the degree and the leading coefficient. So sometimes your degrees are odd and sometimes your degrees are even. So the top 2 here are when the degrees are both odd. So that would be like a cubic one where it's like an x to the 3rd, or you could have an x to the 5th, x to the 7th. That's when you have your degree is odd. Down here your degree is even, so we can have an x squared, x to the 4th, x to the 6th, that kind of function. And then the other one's leading coefficient. So then the coefficient of that leading term, when that is positive or if that is negative. So these 2 are positive over here. So this is when that leading coefficient is a positive number, that number in front of that leading term. And when that number is negative, then it's doing this. Now, the even ones are the ones we should be familiar with because we've seen the x squared ones already. And we know when it's an x squared, which is an even degree, we know when that's a positive term up in front, like your A number, you're going to be opening up. So your arrows are both going to be pointed up. Or if it's a negative number, you're going to be opening down, and the arrows are both going to be pointing down. That would be essentially the behavior of the graph. But now as we get into looking at more like cubic ones or any odd degree functions, one arrow is going to be up and one arrow is going to be down there. You can see it's different. One arrow is up, one arrow is down. So when you have an even degree function, that could be even an x to the 4th function or x to the 6th function, it's going to be the same. Both arrows are going the same direction. But when it's an odd degree function, the arrows are going in opposite directions. So how do we remember this? And here's what we would actually have to say for actually what it's going to talk about. As x approaches negative infinity, our f of x, which is the graph, the behavior of the graph is approaching negative infinity. That's what it's showing right here. So as x goes out this way, your graph is pointed down, so the graph is going to be going down to negative infinity. And also as x goes out to the positive direction towards positive infinity, this graph is going up. So it's approaching your graph, your f of x, which is the graph, is approaching positive infinity. So that's basically what's going on here. So if you can keep these straight, it's really not hard at all to just figure out what you're supposed to do. You know you're going to use infinity symbols. The question's going to be, is it supposed to be negative infinity or positive infinity? So I have a little easy way to remember that. So if you can draw maybe next to this over here on page 78, draw a little coordinate plane, a little x-axis, y-axis. And if you remember back from a long time ago, and maybe from the beginning of this school year, we even reviewed it a little bit, the coordinates, or it's not the coordinates, the quadrants here. There's 4 quadrants. The numbers of these quadrants, go 1, 2, 3, 4. So you have your first quadrant, second, third quadrant, fourth quadrant. Now in each quadrant, you have x and y's here that in this first quadrant, they're all positive. Both x and y are both positive. So I'm going to put, this would be like our ordered pair. X is positive and y is positive. Now remember, x is going to be, as the x approaches, so it's always the end behavior here as x approaches positive infinity or negative infinity. What is the graph doing? The graph is what the y is. So if this is the case, if your arrow is in the first quadrant, like it is here, like it is over here, then you can use positive and positive. You're going to say positive infinity for x, you're going to say positive infinity for y as well. If your arrow is in the second quadrant, well then that quadrant is always where x is negative but y is positive. So your x is going to be negative infinity, your y, or f of x, the graph, is positive infinity. So you can see that was happening here in the second quadrant. You can see that's what we got. X is the negative infinity, f of x, or y, is the positive infinity. Down in third quadrant, we know it's always negative, negative. Both are negative in this one. As you can see here, when it's in the third quadrant, like this one is, both infinities are negative. There's a third quadrant one, both infinities are negative. And then if your arrow is finding itself in the fourth quadrant, and you know it's going to be down there, then it's going to be a positive for x, but negative for the f of x, or the y. And so that's what you see down in this one, negative for the y, but positive for the x. So you just have to realize, where are your arrows of the graph going to be? If it's an even function and it's positive, your arrows are both pointed up, you're going to be in quadrant 1 and 2. And so it's going to have this, you're going to use a positive for this one, and you're going to use negative for x, but positive for y for that one. If it's opening down, it's an even function, so even number for the degree, but a negative opening down, it's going to be in quadrant 3 and quadrant 4. Here, if it's odd, it's in quadrant 1 and quadrant 3 if it's odd and it's positive, leading coefficient. If it's odd degree function, but your leading coefficient's negative, then it's here, 2 and 4. And I always kind of think of this like a line, because a linear function is an odd function. So if it's a positive, your positive slope would go uphill, you're going to be like a line. So you can think of it like that in terms of a line. So if it's an odd function, it works just like the line does. If it's positive, it's going uphill, which would be finding itself in 3 and 1. And if it's negative, it's going downhill, like this one, going from 2 to 4. So that's where your arrows would be. All right, let's go ahead and try something like this now. Okay, so back on page 79, number 7 and 8, just say describe the end behavior of the graph of the function. So that's where we want to use that core concept, refer to that, look back at that to help you. So for number 7, remember, to describe the end behavior, you want to ask yourself the two things: what is the degree and what's the leading coefficient? So really, is the degree even or odd, and is the leading coefficient positive or negative? So first of all, you want to say, okay, our leading term here, what's the leading term? So this is in standard form, so this is your leading term on this one. It's the highest one that has the highest exponent is always your leading term. And what exponent is it? It's a 6. So your degree is 6, which is an even number. So this is going to be an even degree, and your leading coefficient is negative, so it's a negative leading coefficient. So we have even and negative. And so if you go back to your core concept, and I'm going to just put a little table, a little coordinate plane here to show, okay, when it's even, it's negative. If you look at the one that says that, the arrows are going to be here. Remember that when it's even, they're both in the same direction. When it's negative, they're both opening down. So you're going to be in quadrant 3 and quadrant 4 with the arrows. The behavior of the graph is going to be that the arrows are going to be coming out 3 and 4, quadrant 3 and quadrant 4. So that's where x is negative, negative, and where x is positive and y is negative. So here's what you're going to write now. You're going to write down this each time for end behavior. F of x approaches, the arrow would be the word approaches. F of x approaches, and we're going to put an infinity symbol here, as x approaches, and another infinity symbol. So the arrows are going to point to the correct infinity symbols, but this is always going to be the same. So you can say f of x arrow to as x arrow to, and it's going to arrow to the infinity symbols. You just got to write down, is it negative infinity or positive infinity? So you can just take one of these at a time. It doesn't matter which one you start with. So I can do the first one. I could say the y here, negative infinity. Well, they're both negative infinity right now, so I don't know which one I'm talking about yet, but the x one is negative infinity. So I did negative, negative first. There it is. So there's the one in the third quadrant. So as f of x, which is the behavior of the graph, is going towards negative infinity, that's when x approaches negative infinity. So I usually like doing it backwards typically. I look at what the x is doing first, where the x is going at negative infinity. I know one way it's going to be negative for that, the other way is going to be positive for x. It's just really what's the behavior of the graph doing. And so when it's going off into negative infinity, the graph is going off into negative infinity. And the next one, you're going to write the same thing down. F of x approaches as x approaches. So as x approaches the positive infinity, what's the graph doing? It's going down. It's also going to negative. So we're going to have a negative infinity for the f of x, the graph part, as x. And oops, I forgot the x on this one. Oh, don't forget the x to put that in there. So I forgot to put x in there. As x approaches positive infinity. Okay, so number 8. Let's take a look at number 8. The thing about number 8 is it's not in standard form, as you can tell. So you got to figure out, okay, which one would be the leading term? And so you got to look for the one that has the highest exponent, which is this term right in the middle, 3x to the 5th. So that term is your leading term there. And you can see what degree is it. It's an odd degree because it's 5. So it has an odd degree, and the leading coefficient is a positive number. So it's odd and positive. So odd always means arrows are going one up and one down. Positive would mean that it's going from the third quadrant to the first quadrant. So it's 1 and 3. So if we look at our quadrants, it's going to be in quadrant 1 where they're both positive, and in quadrant 3 where they're both negative. Okay, so you're going to write out this again. So the f of x, the arrow as x, and the arrow. And so for one of them, you can just start with one of them. You can start with the negative ones for quadrant 3. They're both negative infinities. That's easy to do. Just put negative infinity on both. You have to have negative, negative on one of them. And the other one, you can write out, again, f of x. This is always going to be the same. It's just what's going to be different is the signs on the infinity symbols. The other one, this one here is positive, positive, so it's both positive infinities. Positive infinity for x, because x goes this way to positive infinity. The f of x is going up. That's where the arrow is pointing, is up. So it's positive infinity there. Okay, so for number 9, it says describe the degree and leading coefficient of the polynomial function using the graph. So basically, here's the graph you want to describe it, like this here: odd, positive, even, negative. Go ahead and pause the video really quickly and do number 9. See if you can do that correctly. Okay, so here you are, number 9. Hopefully you got this one. We got the arrows, one's up, one's down. So you're basically you're in quadrant 2, you're in quadrant 4. So what would our leading coefficient be? So if it's 1 up and 1 down, we know our degree is going to be odd when it's 1 up and 1 down. So you should have said degree is odd. And as far as the leading coefficient, because it's going from 2 to 4, this would be like going downhill, so it's got to be a negative leading coefficient. So if you were to think about, if you were to connect the arrows together with a line, you're going downhill, so it's like a negative slope. So that means you have a negative in front of your x there on that one. So it's a negative leading coefficient. All right, let's move on. Okay, so on page 80, you're going to graph two functions here, two polynomial functions. So number 10, p of x equals 16 minus x to the 4th. First thing to do on the graph there is draw your coordinates here. Draw your x-axis and y-axis here. So make your quadrants by doing that. So you can just go right down through the middle, right across the middle. The next thing we want to do is I would put this in standard form. I think it might be a little more helpful to graph it possibly. So the standard form would be p of x equals negative x to the 4th plus 16. That might help us a little bit as we graph it. We can always check our graphs with the Desmos calculator, especially as some of these polynomial functions can get, really kind of strange and weird looking. They don't follow necessarily a specific pattern sometimes. But as far as this one goes, it's pretty straightforward because there's not much going on. It's a quartic function. We see x to the 4th. So we know the arrows, what's the end behavior? Well, they're both going the same direction. They're both going to be down here. So we know our end behavior is down here. Our arrows of this function are going to be down, going out this way, both headed down. We want to do a little table of values just to find some points, and we can plot those points. So the first point I would pick would be 0. When x is 0, what is the y going to be, or the p of x? So I plug in 0 here. 0 to the 4th power is 0. 0 times a negative is 0. It's just going to be 16 then. So when x is 0, your y is 16. It's the only number it is. And so as we start to graph this, what I'm going to do here to get to 16 is I'm going to go by 2's on the x-axis. So the x-axis I'll go by 2, by 4's on the y-axis. So every box is worth 4 there. And so that puts 16 up here. So 4, 8, 12, and then 16 would be here. So we can plot a point right there at 0, 16. And the next number I would want to know would be 1. Where is it at 1? And so if I plug in 1 for the x, that's now going to basically look like this. It's going to be a negative times 1 to the 4th, and then plus 16 after that. So if you just do 1 to the 4th, that's still 1, and then 1 times a negative is negative 1 plus 16, and so you take 1 away, it's 15. So when x is 1, the y, the output, is 15. So we can plot that point. So it's going to be 1, which is really half a box here, and then goes up 15. So it's fairly high up there. So, oops, sorry, I went the wrong direction. I was going negative 1. I will do that one next. But yeah, positive 1 to the right, and then up 15. And now do negative 1. Go to the left. And if we do that, if you plug in negative 1, how will that change? Well, you still have, if you just think of this as a negative number, 4 negatives will still be a positive. So you'll still have positive 1 times negative. You'll still get the same exact number, 15. So when you plug in negative 1, you're going to get also 15. And so negative 1, 15, just on the other side. The next number I would want to know is 2. So if I just plug in 2, where are we going to be? So it's going to be 2 in for x. So it's going to be the negative sign, then 2 to the 4th, then plus the 16. And 2 to the 4th is 4 2's multiplied together. 2 times 2 is 4, 4 times 2 is 8, and then 8 times 2 is 16. So we're going to get 16, and then multiply it by negative. So it's negative 16 plus 16, which would give us 0. So when x is 2, the y is 0. So we can plot that point. 2, 0 is going to be right on the x-axis right here to the right. And if you think of the next number you'd want to know, negative 2. And if you plug in negative 2, is that going to change? Is it still going to be 0? And yeah, it will still be 0 because negative 2 to the 4th is still going to be 16 times a negative, making negative 16 here. and that's still going to give you 0 for the output for the y. And so when you go to the left 2 units, right here is going to be also a point on the x-axis. And that really isn't enough point. So it does kind of look like a parabola. It's just a little flatter up here on the top. And so you can draw your U, kind of U shape. Remember, these are going to be somewhat of a U shape. Sometimes they're also W shaped on these ones. So you could have even a W shape sometimes. You just know that the arrows are both going the same direction. They're both going down on this one, or they might be both going up. But you could have it looking like a flatter U with this one, or you could even have a W as possible as well. Now the next one, number 11, this one I would say is a little more challenging. First of all, we want to make this into standard form. Go ahead and draw your coordinate plane as well, x-axis, y-axis, do the same thing there. I would put this also in standard form. That way I can see the leading term there, 3x to the 5th plus x squared minus x. And so with this one, I notice it's an odd degree. So one arrow is going to be up, one arrow is down. It's an even leading, a positive leading term. So it's going to be kind of going uphill. So we should have one of the arrows in the third quadrant, the other arrow in the first quadrant. So it's going to be doing that kind of thing here. So now we just go to a table of values. So x and y t-chart. Let's start to plug in some numbers. Again, the first number I would choose would be probably 0. And on this one, I'm going to go by ones. Every one's going to be 1 as we start to plot these out. So every box is going to be worth 1 unit. So if I try plugging 0 in here, as you notice, you plug 0 in, this term is going to end up becoming 0, this term is going to end up becoming 0, and this term is going to end up becoming 0. They all become 0. So if everything becomes 0, you have a point at 0, 0. So we know we can plot a point right there at the origin. The next number you might want to know is positive 1. So you can try putting positive 1 inside here and figure out what you get. So if I do 1, and I put 1 in here, it's going to see 1 is going to get squared. So I'll do it down below. It's just doing that evaluation like we did on the last, like I think it was problem 5 and 6, we were doing an evaluation. You're basically doing that, but you're just choosing the numbers you want to plug in for x. And so I'm choosing the number 1 to plug in here to see what would I get if I plug in 1. So when I do that, 1 squared, and then it's going to be 3 times 1 to the 5th, and then negative times 1, which means negative 1. So this is going to be a 1 here. This is going to end up being 1 times 3. So it's 1 plus 3 minus 1. And the 1's basically going to cross each other out there. It's just going to leave you with 3. So our output for that one is 3. So we're going to see a point at 1, 3. So we can plot that point right up here in the first quadrant. So put a point up there. The next number you might want to know is negative 1. So it's always good sometimes just to go back and forth here and do positive 1, negative 1, and so on. So if I try negative 1 and put that in there, it's going to be negative 1 squared, and then positive 3 times negative 1 to the 5th power, then negative 1 times negative 1, or negative times negative 1. So right here, negative 1 squared, this is going to be 1. This is going to be a negative 1 here because 5 negatives is going to stay negative. So it's going to be negative 1 times 3, which will make a negative 3 here, and then this will be a positive 1 in the back. So we're going to see it as positive 1, negative 3, positive 1. And so we're going to, if we can put the two positive 1's together, that's going to be 2, and then take 2 away from negative 3, we're going to get negative 1. So negative 1 is another point on this graph. We can plot that over here in the third quadrant. So put that one down. Now if I tried 2, you might be thinking, okay, let's try 2 next. Let's just play that out. I'm actually not going to write it down, but let's just try it out real quick. If you put 2 here, that's going to end up being 4. If you put 2 here, 2 to the 5th power is going to be 32. Then 32 times 3 is 96. And if we add 96 to 4, that's 100. So you have 100 so far just right there. Minus 2, that would be 98. Well, where is that going to be? And when I put 2 and then 98, that's way higher than what I even can show here, right? So I'm going by ones. This, as high as I can go, is 5 this way. So when I'm at 2, I'm going to be so far up here, I'm not going to be able to write that on here. So you might be thinking, well, here we go. Let's just do it like this. It's going up that way, and it's coming down this way. And you might think, well, that's pretty good. That's not exactly what it's doing, though. So yes, from this point here, the arrow is going to keep going up, and from this point here, the arrow is going to keep going down. But between these numbers, between -1 and 0, something's going on. Something's going on here. It's not just doing a slight little curve here. We're going to look at that here in a minute. And also between 0 and +1, something's going on here as well. So the best way to see that for some of these here, where they're just going to continue to go further and further, we want to use the Desmos calculator. And you really should always check these. So let's go to the Desmos calculator. I'm going to type this one in first just to make sure we did this one correct. So let's come over here to Desmos. Okay, so I typed in our first function there, the one we just did, which was the -x⁴ plus 16. That's the standard form of that. You can put y equals this, but you don't need to. And we did it correctly. It looks like what we drew down here. But now let's take a look at the other one as well. I'm going to type that one in, and I'll show you that. Okay, so here it is. I just need to put this last little part in here, minus x. This was the standard form, 3x⁵ plus x² minus x. And now we'll see what that graph looks like. So here it is. And let me zoom out a little bit here so you can see. Actually, I need to zoom in, really, because I need to see what was the window we had. We had like kind of 5. So our window was like 5 there. So you can see 5 there at the top. Well, let's go down a little bit. So there it is. That's pretty close to what we had here. So notice there's our 1, there's 1.1 right here. We had that point on there. Where'd it go? Yeah, there it is, sort of past it. It's right in there. It is, -1, -1. We saw that point already. We saw 0, 0 already. We saw a point up here at 1, 3. So that's the point we had here. And down a little bit, it was too far. There it is, 1, 3 is on the graph. But now notice what's going on here. See how what's happening? It's not just going slightly, it's not going slightly up through here. There's a point where it's going up through and down over. So we have an x-axis point right here, x-intercept, another x-intercept point right there. So it's not just going straight through 0, 0. So 0, 0 is not the only x-intercept. We need to realize there's these other two x-intercepts. This would be like -0.90 and 0.6 and 0. So we got to include those points on our graph. We also have to include the points where it's like the max and minimum points. This one actually has a max point right here. So that's a max point. Let's get rid of that one. Here's a minimum point. So -0.6 and then 0.7 is a max point. maybe 4 here if we run that up to 4. And then -0.2 is a midpoint. So we need to see it's going to go up through this x-intercept, hit the maximum, come down through 0, hit this minimum point, go back through this x-intercept, and go through the point we already drew and keep going up. So that's what we needed to really see what was going on there. So even if I zoom in a little more, you can definitely see we got this roller coaster happening between -1 and +1. You have a roller coaster. See, there's -1, +1. So then you have this roller coaster happening here that you need to include in our graph. So let's do that on our paper over here. Let's put in the points that we just saw. So one of those points was -3.6. Positive 0.36 for x and -0.2. That point's going to be right here. So if I go this way just a little bit and then down just a little bit. Another point is going to be the -0.6 and 0. So that's going to be also on the right side a little bit, just not quite to 1, but on the x-axis. That's in one of those x-intercepts we got. Another point we needed to put down was -0.6 and a 0.7. So that's going to be going to the left a little more than halfway and up a little more than halfway. So it puts it up right there. And then our last x-intercept that we saw was -0.9 and 0. That's almost to 1 here, but not quite to 1, but on the x-axis. So now we can draw it knowing these points. So here we go. We're going to go up through this x-intercept, hit the maximum, come down through the 0, 0, hit the minimum, go through that other x-intercept, and then out through that last point. So go ahead and draw that. That's what it really should look like. That's what our graph is going to be on this one. All right, so we're ready. We're going to do just one more, just number 12. We're going to skip 13, and then we should be done. Okay, so problem 12 says, sketch a graph of the polynomial function f if, and it gives you some end behavior here, if it's increasing when, actually increasing, decreasing parts here, which is kind of the behavior of the graph. So not necessarily just end behavior, but f is increasing when x is less than -1 and when it's between 0 and 1. It's decreasing when it's between -1 and 0 and also decreasing when x is greater than 1. And f of x, the graph itself, is less than 0 for all real numbers. So the graph is less than 0 for all real numbers. So first of all, what we notice here on these parts here is we have three numbers up here. -1, 0, and 1. So go ahead and you have your little coordinate plane, draw your x-axis and y-axis, and we're just going to say every one of these is just worth 1 unit. So we already have 0 right here, 0, 0, but let's highlight maybe 1 and -1. So I'm going to put little marks here to highlight. Here's -1, here is +1, 0 we already kind of have it marked off here with the y-axis. And also, another thing we notice here, it says that the graph, the entire graph, is less than 0 for all real numbers, which means that's below the x-axis. So our graph is completely below the x-axis here. Okay? So let's go ahead and through this. It's increasing when x is less than -1. So less than -1 is over here. It's going to be increasing. It's going to be coming up when it's on this side of this -1. Coming up. So over here is where it's increasing on this side here. And also then what is it doing then after -1? So between -1 and 0, that's this part right here, it's decreasing. So that part's decreasing. What's happening between 0 and +1? That's this one right here, between 0 and +1, it's increasing. So it's increasing in that little increment. And then once we pass +1, what's it doing there? Well, that's where right here it says when x is greater than +1, it's decreasing again. So decreasing on this side. So it's increasing, then it's going to, as soon as it hits this, it's going to change direction and decrease, then it's going to increase, and then it's going to decrease. So here, let's go ahead and graph this, and it's all going to be below the x-axis. So we're not going to cross the x-axis at all. Everything is down below it. So we're going to start down below here, kind of come up, and just before you get to the x-axis, you're going to have to stop and be ready to turn. So come up there to 1, or -1 I should say, and then be ready to turn, because now we're going to turn towards the 0. So now we're going to come down, and once we cross 0, we're going to turn and go back up until I get to +1, and then I'm going to turn again, and then I'm going to just go out the down side here and put my arrow on this one. So this would be one of those where we can see what the end behavior is. That's what this last part is asking. Describe the degree and leading coefficient. That's kind of like the end behavior. So the degree, since they're both pointed down, we know it's an even degree. So I'm just going to put even for the degree. And because it's down and not up, okay, when they're both pointed the same direction, it's even. When it's down, that's definitely negative leading coefficient when they're both going down. All right. Okay, so I have one last little exit slip for you before we're done. Okay, so here's this little exit ticket. You can do this back on just maybe one of those notes pages. It just says, what do you know about the graph of this function without actually graphing the function? So what can you tell us about the graph? Which means, you know, which way, you know, what's the end behavior? You know, where is it going? You know, what's it doing? All the stuff that we just talked about, everything you can tell me about this graph so far we've talked about in this lesson, go ahead and write that down and enter that also on, if we're doing it on Edpuzzle, go ahead and enter it on Edpuzzle. Okay, so you should have written down as much as you know about this graph. So I'm just going to show you what you should have written down, see if you included some of this stuff here. So what you could have written down is that the degree of this function is an even degree. That's 4 there. The leading coefficient is a positive, as that's a positive 3.5. The end behavior, you can see because of that, the graph, the f of x approaches positive infinity as x approaches negative infinity, because we know it's going to be even and positive. They're both opening up. So that would be like in quadrant 2, when x is negative but the y is positive. And then positive, positive also. F of x approaches positive infinity as x approaches positive infinity. That's because it's positive, positive. You could also tell me that the y-intercept is 2. Now, you may not have remembered that, but you can tell me that because if you plug in 0 here for x, you're going to get 2, and that would be the y-intercept. Your constant number back here is always your y-intercept. All right, so that concludes our lesson for 4.1, and you're ready for the assignment, and then I'll see you on the next video. Have a great day.